Hello, happy half term. Huge thank you to my Year 12 Computer Science students who've worked so hard this half term, especially those who've been involved in the CanSat project. Some of you have worked really hard at school and have been in touch to see how you can continue that at home. There's absolutely no pressure or obligation to do that, but I hope that this video will give you an overview of how you can continue to be involved in CanSat remotely, but also just generally how open source software works using GitHub, how you can get involved in any large collaborative code project. So just a reminder, you're already very good at the weekly C# challenges. If you're not very confident at C#, that is the best way to do it. Watch the support videos, work through the weekly challenges. If you want a bit more of a challenge, then live.withcode.uk/A-level will let you generate a random challenge from the OCR list of coding challenges, and then you can try and work on one of those and submit a solution on here for a prize. But I want to focus on CanSat today. So a quick reminder, CanSat is a project sponsored by the European Space Agency, where we're going to send a Raspberry Pi Pico device up in a rocket. It'll get pushed out of the rocket, fall with a parachute, and whilst it's descending, it will measure pressure, altitude, and temperature. It will measure GPS coordinates and accelerometer values and magnetometer values, so you can work out which direction the Earth's magnetic field is, as in which way the satellite is facing. All of those sensor values will be logged on the device, but also sent via a long-range radio, received on the ground via that big Yagi antenna that you've seen me walking around with up and down the field. I get some odd looks, but well done for building that and putting that together. We've got another Raspberry Pi Pico that will display all of the sensor values on a tiny little screen, but then also send them via USB to a laptop, and that's the project that I'd like you to be able to get involved with at home, and thank you for your hard work in that project so far. So if you want to do that, the first step is to log into GitHub with your school account, or you can make one for free using your school email, and fork this repository. That means that you take your own copy of all of this code, you create a fork. I need to choose, a different user. Let's try that. You can just keep the same name with your username, that should be fine. This means that you'll have your own copy of the CanSat repository, which you should then be able to edit without fear of messing up anything for anybody else. Then you want to get that code in Visual Studio. So you might not have the link that says open with Visual Studio unless you've used that before, but you will definitely see that code link here. So remember, we're using Visual Studio Community Edition, which is the free edition, but not Visual Studio Code. Right, I want to clone a repository, paste in that link from GitHub, and then we should get the code on here. The way an open source project works is you don't generally have access to read and write to that actual repository. You fork the repository, you have your own copy, you commit your changes to that, your own version of that repository, and then if you manage to solve a bug or improve something, you open a pull request to let the project owner know that you've done something worthwhile, and they can choose to integrate it with their project. All right, when you run it, it will try and look for the CanSat device, and obviously if you're at home, like I am, it won't detect it. But with some students, we have written a simulated CanSat, so you still will be able to see all of the sensor readings, or kind of imaginary sensor readings. So if we click on Solution Explorer, right-click on Ground Station User Interface, and Set Startup Project, let's try and run it again. This time, hopefully, you should see a WinForms project. Great, there we go. If CanSat, the physical device, was detected, you'd see it here. It's not, so I'm going to go for the test device and connect to that, and hopefully we should see some simulated test sensor readings like AX for accelerometer X values, AY, AZ, or MX, MY, and MZ for magnetometer readings, temperature, altitude, all of that. We've got some of the graphs working, but not all of them. So you'll notice we have some imaginary accelerometer values here. If we go back to GitHub and the main master repository, you'll see some issues in here. Now, issues are where anyone can suggest a problem or a feature request. You can file a new issue if you spot a new problem. But let's start with this one. Add labels for X, Y, and Z for accelerometer values. You'll see here we've got 3 traces, but we can't see which is X, which is Y, and which is Z. So let's click on here. Notice that this is issue number 1. We're going to try and work out how to do this. And then I'd like one of you to finish that solution, file a pull request, and I will merge that in with the actual repository, and you'll have contributed to an open source project, possibly for the first time, which I think is almost quite exciting. All right. How do we do that? Well, I know some of you have been working on that at school, done a bit of research, which will hopefully help you out. Let's see if we can get started. So I've expanded Ground Station UI. For me, Visual Studio doesn't straight away recognize that this is a WinForms project. I have to kind of open and close the project. There we go. It's finally recognized it's a WinForms thing, so I can double click on it and it opens in the designer. We had some problems with Scotplot, which is the graphing library. We couldn't drag and drop the graph controls without crashing the application, so we had to do that with code. So you will see the code for adding in the temperature and accelerometer plots in here. So this is the event handler for when the program loads. If we find the section for adding the accelerometer graph, we have 3 data loggers, one for X, one for Y, one for Z. All of them get added into one acceleration plot, Scotplot, WinForms plot thing. And that's what we can use. So the acceleration plot object has a plot object inside, and there should be a show legend method, which is what we want. A legend is the set of labels on a graph. Control, Shift, and Space. Look, there's 2 versions of it. One to say where it appears on the screen, and another one to show a list of items, and that's what we want for X, Y, and Z. Okay, so we'll start with where to put it. I would like to have a list of legend items. That doesn't exist yet. Oops, come on. And then the location, so Scotplot alignment dot. I would like lower right. There we go. So let's make this legend items thing. What is it supposed to be? Control Shift Space. An enumerable, an interface to an enumerable object. That means a list or an array, something that you can iterate through. And inside the list or array, it should have legend items. Okay, so let's make an array, legend items. Sorry, each one is just going to be an individual legend item. I want an array of them, legend items, and then we can, at runtime, add in lots of those legend item objects. So let's call the constructor for a legend item. And then we should be able to specify the label. Let's have X. Will that work? Nope, that doesn't work. In C# you have to call the constructor, and then you can pass in any public property values, public attribute values here. Label equals X. There we go. We can also specify other attributes. How about the color? Can we set the color, the line color? Right, so we've got the X logger object here. That should have an attribute called color, so that the line on the graph matches the legend item down at the bottom. All right, let's add in another one for Y. This time the label is Y. The line color is, oops, what have I done here? I want another legend item That's better. And when you do it, you'll have to put in another one for Z as well. Set the label, set the colour. And then hopefully, if we run it, pressing F5, this time the acceleration graph has a legend on it, but when you do it, it's going to have X and Y and Z. Okay. So hopefully when you've done this, you will have done the code on your computer at home. You'll see a little pen icon at the bottom. Don't know if you'll be able to see that because my video is probably in the way, but there's a little pencil icon with a 1. If I click on that, you can describe what you've done. So added legend for accelerometer graph. But I'm also going to say which issue that addresses. So this is issue number 1. So let's say closes, as in completely resolves, issue number 1. All right, I'm pressing commit. That means that I've saved the version of the project code just onto my computer, but it's not going to be on GitHub yet. To put it on GitHub, we'll press the push button, and that will push your committed code onto your version of the repository. That's the one that you forked. If you want to send a message to the project owner to say, I've resolved that issue, you need to open a pull request. That will send you to GitHub. You can describe what you've done. Look, we've got the details already on here from GitHub. I'm not going to press the pull request, create pull request button. I'd like you to be able to work through this because I haven't done X, Y, and Z. But hopefully, when you've done this, I'll get an email that says so-and-so has worked on this particular issue, and I'll see your code. I'll be able to pull that into the master repository, and you'll be able to continue working on this at home. So once you've done that, you can work through any of the other issues on here. You can file a new issue, as in something that you'd like to work on, something that you'd like to improve, or a bug that you found. Or if all of that's too much, remember, you will get to this stage where you are that confident if you regularly work through the weekly code challenges, you push yourself a little bit harder, or you get involved in an open source project like this. So I hope this is helpful. Hope you have a really good break over half term. Remember, there's no obligation to do this, but some of you have asked about it. You're working really hard in school, and it would be great for you to be able to know how to get involved in open source projects like this out of school. All right, all the best. See you in a bit. Bye-bye.